Hello students, let us discuss modern periodic table in this video. In 1913, Moseley, a young English physicist, discovered that atomic number is the fundamental property of the atoms. Therefore, he suggested that atomic number instead of atomic weight should be the basis of classification of element. As we have discussed, in the case of Mendeleev periodic table, the elements are arranged in the increasing order of atomic weight. But it was concluded that atomic numbers are the fundamental property of the atom. Therefore, he suggested a periodic law, that is modern periodic law. It states that the physical and chemical properties of the elements are the periodic function of their atomic numbers. The more importance was given to atomic numbers. So that is about the modern periodic law. Let us find which one is modern periodic table. This is called as modern periodic table or long form of periodic table. This is the periodic table which was accepted by the IUPAC. Now this is taken as a periodic table for the studying the classification of elements. So let us discuss more about the modern periodic table. In the modern periodic table, the elements are arranged in the increasing order of their atomic number. When you can find out when we go from left to right hand side, we can find out that the atomic number are increasing. Thus, the importance was given to atomic numbers, not the atomic weights. So when you find it out that atomic number start from the left side and till the right hand side, we need to arrange the elements, and in all the cases we can find that the elements are arranged in the increasing order of their atomic numbers. So when you find out the first will be on the hydrogen, then second is helium on this side, then lithium, barium are this side, and the other are on the other side. So we will be discussing these elements arrangement in detail. The block is, that is, the periodic table is divided into 4 blocks. That are, we can find out the 4 blocks here, which was given separate colors here. The block which is on the extreme left hand side, that block is called as S block, and the block which is in the middle, that is named as D block, and the block which is on the extreme right hand side, that is named as P block, and the block which was kept separated from the main block, that is called as F block. So thus the periodic table, that is a modern periodic table, having 4 blocks. These are S block, P block, D block and F block. Now you will be thinking why there is a need of separate blocks and why the arrangement is not in a regular way. Here it is actually can find the blocks, and some blocks are vertically aligned, some are horizontally aligned, and why the F block is kept separate, that all we need to discuss in this video. Here the elements are represented in each boxes, that is in this way. That is, in the periodic table, the symbols of each elements are represented, that you can find symbols of are represented. Cobalt is represented by the symbol CO, and you can find out the atomic number was written and the name was written for that element, and even the atomic mass is written. And even you can find out the electronic configuration also written, that is the outermost electronic configuration of the element is written. So the elements in the periodic table are represented in this way. But usually, always it is not found to write the electronic configuration and name. Usually we found in the periodic table only the symbol and the atomic number you can find in the periodic table. But when we have a chart of periodic table, a big chart, in that you can find out electronic configuration, name, atomic mass, all is written. But in this periodic table which I have shared in this video, in this we can find out only the symbol and its atomic number. Similarly, we can say that oxygen atom, in this how we write oxygen atom, that is in the symbol form oxygen O and its atomic number. So in the periodic table you can find out the elements are represented, that is elements are represented in this way. When we zoom it out, we can say that the each elements are clear here. If I zoom it this table, I can find out that the oxygen atom is written on the side, and when we find it out, its atomic number is written there and its name is also written. Similarly, if I zoom it and another element like this, calcium you can find out it is on this side, its symbol is written, atomic number is written, that is 20, and its name is also written. So in the periodic table we can say that the elements are written, its symbol and even its atomic number, and the name is written. In the modern periodic table, you can find out there are some horizontal rows. Horizontal rows, when you find it out, this is one horizontal row, this is one horizontal row, this is the third row, fourth row, fifth row, sixth row, and the seventh row. There are 7 horizontal rows in the periodic table. That is a long form of periodic table. These horizontal rows are called as periods. That is, the horizontal rows are given the name, that is periods. So we need to discuss what is periods. Periods are the horizontal rows in the modern periodic table, that is named as periods. Just like in the Mendeleev's periodic table, the horizontal rows are called as periods. Similarly, in the modern periodic table also, the horizontal rows are called as periods. So whenever we talk about period, we need to consider the horizontal row. So as we have discussed, there are how many rows here? That is, we have first row, second row. Similarly, we can find out there are 7 rows. So we can say that in the modern periodic table, there is 7 periods. Why it is have 7 period? When you observe the table here, there are 7 horizontal rows. Therefore, these are called as 7 periods. In this, we also find out some vertical columns. Vertical columns, you can find it out in the modern periodic table. That is, this is a vertical column. Second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We can find out that total 18 vertical columns are there. These are named, these vertical columns which you can find out, there are 18 numbers of vertical column. These vertical columns are named as groups. So whenever I talk about a group, you have to consider a vertical column here. So we can say that in the modern periodic table there are seven number of horizontal rows which is named as periods, and there are 18 number of vertical columns. You can find out the number is written here. So we can find out that each vertical column is represented by a number. So we can say that there are 18 number of groups. So once again, the modern periodic table have 7 horizontal rows, that is 7 periods, and there are 18 number of vertical columns, therefore it have 18 groups. Now you'll be thinking why I've not included this part in my numbering of rows and numbering of period. Why I have not taken this in the numbering of rows, that is a period and group? Because thus in the modern periodic table, after lengthanium, we can find out this part, the highlighted part is taken separately, that is in that the filling of f orbital is taking place, so that is taken as separately. So if we take this group in that portion, we can find out the table will be in this way. So you can find out the table will be in this way. When you count it in this way, you will be getting the 7 periods here. So in the modern periodic table, but it is more convenient to write this modern periodic table in this way. So this is the most accepted way of writing the modern periodic table, not this way. So this is, we are writing in the regular manner, that is after lengthanium we are keeping the next element, not in the separated box. So this part we are taking separately in the other block, that is F block. So the modern periodic table will be in this way. So this is the most acceptable way of making a periodic table, that is a modern periodic table. In this periodic table, let us count the number of elements present in each period. So we'll be counting in the first period, that is in the first period we can find out only 2 elements are there. Therefore the number of element in the first period is 2. In the second period we can find it out, there are 1, 2, 3, 4, 5, 6, 7, 8 number of element. Therefore we can say that the number of element in the second period in the modern periodic table is 8. Similarly, when you count the number of elements in the third period, we can find out there are 8 number of elements. In the next, that is in the fourth period, we can find it out. Here. There are how many number of elements when you count it? There are 18 numbers. Similarly, in the next also 18 number. In the other two we can find it out, 32 number of elements are there. So when we make the sum of all these elements, that is in the first group it have 2 number of element, in the second 8, then 8, 18, 18, 32, 32. So when we find it out that these are the number of elements present in each period, that is 2, 8, 8, 18, 18, 32, 32. When we make the sum of all these, we can find it out there are total 118 elements are present in the modern periodic table. From this, there are man-made elements also, that is an artificial element, and there are natural elements also. In the modern periodic table, if we talk about a particular group, let us talk about the group second, that is this group. We can find out there are elements like beryllium, magnesium, calcium, strontium, barium, radium. That means if we talk about the group second, we can find out these elements like barium, magnesium, calcium, strontium, barium, radium. In the modern periodic table, each element have a particular group and particular period. Let us take one example, germanium. In the case of germanium, you can find out that it belongs to the 14th group and it belongs to the 4th period. So this is germanium. Germanium, you can find it out. It belongs to the 14th group and it belongs to 4th period. So that means whenever we talk about an element in the 14th group, 4th period, that is actually germanium. Let us take one more example. Let us take one more example, that is calcium. The calcium belongs to which period here? The calcium belongs to the 2nd period. You can find out, sorry, it is 2nd group and it belongs to the 4th period. So this calcium here, you can find it out, the calcium here, it belongs to the 2nd group and the 4th period. So each element have a particular group and particular period. Let us take one more example. Let us take an example, that is copper. Copper, let us find out the group for the copper, that is the 11th group is the copper and it belongs to 4th period. So like this you can find out each and every element in the modern periodic table belongs to particular group and particular period. Now in the periodic table, that is a modern periodic table, the question arises why it is divided into blocks. That means you have find it out in the periodic table. There are certain blocks here, that is S block, P block, D block and F block. Why they are arranged in the blocks? Because here, as we have discussed, atomic numbers are given importance here, not the atomic weight. Since the elements are arranged in the increasing order of atomic number and atomic number give rise to a particular electronic configuration. So when we find out the electronic configuration of some elements like lithium, sodium, potassium, rubidium, cesium, francium, when we find it out, these are the elements in the group, that is these belongs to the group, first group, that is lithium, sodium, potassium, rubidium, cesium, francium. So these elements, when we look at the electronic configuration here, we can find it out they have similar pattern of electronic configuration. When we find out the outermost electron, that is the electron which we have filled last, that electron, in the case of lithium, you can find it out that electron is in 2s orbital. In sodium, it is in 3s. It is in the 4s in the case of potassium. Rubidium 5s. Cesium, you can find it out, that is in the cs 7s, etc. So you can find out that the last electron is in the s orbital. Because of this reason, these elements are belonging to the s block elements. So why these elements are particularly kept on the s block? Because these elements, the last electron is in, that is the outermost electron is in the s orbital. So you can find it out, they have similar pattern of electronic configuration. Similar pattern, when we find it out in all these cases, there is particular type of electronic configuration in which the outermost electron is in the s orbital. So therefore we can say that because of this reason, they kept in the s block. Similarly, if we find out the elements like beryllium, magnesium, calcium, strontium, barium, radium. These elements belongs to which group here? These elements belong to the group second. So, why they are belonging to the S block? Because the electronic configuration when we observe for these element, that is, it is observed that they have similar pattern of electronic configuration in which the last electron is in the S orbital. When you find it out for the all case, you can find out the last electron is in the S orbital. So therefore they belongs to the group second, that is in the S block elements. So that's why these elements belong to S block. Similarly, if we take the case of the examples like the element boron, aluminium, gallium, indium, thallium. When we observe these elements in the modern periodic table, you can find it out these elements belong to the group, that is boron, aluminium, gallium, indium. These belong to 13 group. 13 group which is actually in which block? Thus, these belong to P block element. Therefore, when we observe its electronic configuration, we can find it out that they have similar pattern of electronic configuration in which the last electron is in the P orbital. You can find it out, it is in the P orbital. So we can say that the electronic configuration have similar pattern of electronic configuration in which the last electron is in the P orbital. When you find it out the electronic configuration, you can find it out all cases. You can find out the last electron is in the P orbital. Therefore, these elements, that is boron, aluminium, gallium, indium, thallium, it belongs to the P block element. Thallium is Tl, not Ti. So this is all about the arrangement of element in the modern periodic table, that is in the based on the atomic number. So similarly in the case of D and F block element, we can find it out the elements are arranged. Why it is in the D block such element? That is when we find it out here, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, and other all elements. You can find it out why it is in the D block, because the outermost electron belongs to D orbital. Therefore, they are in the D block. Similarly, the elements of F block element, that is these elements are, when we find out the electronic configuration, the outermost electron is in the F orbital. Therefore, this is taken in F block elements. So the elements are arranged according to their atomic number, and the atomic number give rise to electronic configuration. Because of the particle electronic configuration, they are arranged in the particle block. So that is about the rough idea about modern periodic table, and we know that the modern periodic table is based upon the electronic configuration. So each group have a particular general electronic configuration. So that we'll be discussing in the next video. So that is all about this video. We have introduced the modern periodic law, and we have find it out how the elements are arranged. They are arranged in the increasing order of atomic number, and we also discussed that there are number of vertical columns and horizontal rows, and depending on that there are 7 period and 18 groups. And we also discussed that why they have classified the elements into different blocks. So this is all about a rough idea about the modern periodic table. So in the next video we'll be discuss the further details. So thank you everyone.